Hello and welcome back to Teachita. Today we're gonna finish up the integrating factors and we're looking at our last form. So if there is a function in the form of y prime plus y fx equal to rx, this will turn into a first degree linear differential equation. But how do we do that? So let's break this up to dy over dx. What are we going to end up with? It will turn into an equation in the form of plus dy equal to 0. From here we can say that dp over dy is equal to fx and dq over dx is equal to 0, and then if we do the minus that we were talking about, we'll end up with fx. And then from here we know that f would be, and then fx divided by 1, correct, because of this, and then f would be equal to e to the power of integral of fx dx, which is a very simplified form. So from here on, then we can say, if I call this hx integral of fx dx, then the final answer is in the form of y equal to e to the power of minus hx integral of rx e to the power of hx dx plus c. You need to memorize this. This is very important. This is the final answer, and it's very easy to solve as soon as you can notice fx, and then you have the final answer in this form. Also remember, if we have equation dy over dx instead of y prime, then just let's put it this way: dy over dx x fy is equal to ry. Then in the equation above, swap x to y. Simple as that. So now let's take a look at some examples. The examples are fairly simple and straightforward. So let's say y prime minus y tan x is equal to 2 cosine x, correct? So remember, in the main form we are looking at y prime plus y fx equal to rx, correct? So from here I can say my fx is equal to minus tan x. Be very careful about these minus and pluses. And then rx is 2 cosine x, correct? So from here, hx, if you remember, is the integral of fx dx. So basically integral of minus tan x dx, which is minus ln cosine x. And from here, if we plug it into our main formula, I'm gonna end up with 1 over cosine x integral of 2 cosine squared x dx plus c. And then you will solve this, and that's your general solution. Let's take a look at another example. y prime minus y is equal to, example 2, x squared cosine x. So let's do a simple multiplication. Let's do a simple simplification. I'm going to divide by x. So I'm going to end up y prime minus y over x equal to x cosine x. So therefore, my hx is going to be integral of minus 1 over x dx, or minus ln x. From here, again, very simple, y would be x integral of x cosine x over x dx plus c, which these two cancels out, and the answer is pretty straightforward from there on. Let's take a look at another example. Actually, I'll rather go to a blank page. So in this one we have x y prime minus y over x squared plus y over x equal to e to the power of minus x. So we're gonna just do a quick change of variable, t equal y over x, and then from here you will notice that t prime is equal to y prime x minus x prime y, which is y over x squared. So your equation changes to t prime plus t equal e to the power of minus x. From here, h of x is equal to integral of dx, which is x. Therefore, I can write down y over x, which was t, if you remember, equal to e to the power of minus x integral e to the power of minus x e to the power of x dx plus c. Simple as that. So be aware of the change of variables that might eventually help you a lot. Let's take a look at another example in such form. So let's say I'm gonna call lambda is equal to 1 over cosine y, and then I'm gonna solve this equation using this change of variable. So the equation is sine y dy over dx equal to cosine y 1 minus x cosine y. Correct? So remember, we said lambda is equal 1 over cosine y. So from here, I can simply say y prime sine y. Remember here, cosine y is equal to 1 over lambda, right? So y prime sine y is equal to 1 over lambda squared d lambda over dx. Correct? So now I can rearrange this. 1 over lambda squared d lambda over dx is equal to 1 over lambda 1 minus x over lambda. That being said, I can write down d lambda over dx minus lambda is equal to minus x. So this is like lambda prime, right? So from here, h of x is equal to integral of minus dx, which is minus x, and again lambda would be e to the power of x integral of minus x e to the power of minus x dx plus c. Correct? And that's another way of solving this equation. Let's take a look at one last example. We have 1 plus y squared dx is equal to tan inverse y minus x dy. So again, let's divide by dy. We're gonna get dx over dy plus x over 1 plus y squared is equal to tan inverse y over 1 plus y squared. Correct? So from here you can see that h of y is integral of 1 over 1 plus y squared dy, correct? Yeah. And this is tan inverse of y. How beautiful. Remember we said if it's dx over dy, we want to just swap x and y. So x would be e to the power of minus tan inverse y integral of tan inverse y over 1 plus y squared e to the power of minus tan inverse y dy plus c. And then from here you can see that this is basically u e to the power of u du, u prime e to the power of u du, and it's fairly easy to solve this. So that's it for integrating factor for this course. Next lecture we're going to start the Bernoulli equation, and then a new piece of knowledge will be added to this course as well. Thank you very much, and see you guys next time.